In this video, we'll be focusing on solving IB Physics past question of topic 2 mechanics. So this is paper 1 question for HL student. A block of mass 1.0 kg rests on a trolley of mass 4.0 kg. The coefficient of dynamic friction between the block and the trolley is 0.3. A horizontal force F is equal to 5.0 Newton acts on the block. The block slides over the trolley. What is the acceleration of the trolley? So this question here is tested on Newton's law. Acceleration is equal to net force over the mass of the object. So to solve this problem, we need to find the net force on the trolley. So we know this is a block, and the block receives a force of 5 Newton, and at the same time also receive a force of friction. And friction is equal to coefficient of friction times normal force, which in this case, normal force is equal to the weight of the block. And the weight of the block is equal to the mass times gravitational acceleration, which is equal to 10 Newton. So the friction here is going to be equal to 0.3 times 10, which is going to be equal to 3 Newton. So here is 5 Newton here. And here is also going to be a 3 Newton of friction. And according to Newton's third law, we know that there's always going to be a force that's equal in magnitude but opposite in direction. So if there is a left force of 3 Newton acting on the block, there's also going to be a force of 3 Newton that point to the right direction acting on the trolley. So this is the net force for the trolley here. So the net force is equal to 3 Newton, and it has a mass of 4 kilograms. So the net acceleration is going to be equal to 0.75 meters per second squared. So the answer will be C. The momentum of an object changes by delta p in a time delta t. What is the impulse acting on the object during this change? So this one basically is testing you about the relationship between impulse and momentum. So we know impulse is equal to change in momentum. So impulse is equal to net force times change in time, which is equal to change in momentum. So this problem, the answer will be A. And here is represent the equation represented by different symbol. And this equation is very important for your understanding of mechanics. Which of the following is a condition for an object to be in transitional equilibrium? So we know when an object is in transitional equilibrium, the net force of the system, or the resultant of the system, resultant force of the system must be equal to 0 Newton. So D is the correct answer. So A says the object must be moving at a constant speed. This is wrong because the object can also be in stationary. B says the velocity of the object in any condition must be 0. This contradicts with option A. So for an object to be in transitional equilibrium, it can be either stationary or moving at a constant velocity. So both A and B are wrong. The forces acting horizontally on the object must be equal to the forces acting vertically on the object. So forces does not impact each other unless they're in the same direction. For example, upward force only affect downward force, and rightward force only affect leftward force. A projectile is fired from level ground with speed v at an angle theta to the ground. Ignoring air resistance, which of the following is a correct expression for the maximum height reached by the projectile? So a projectile motion is something look like this. And here will be the range. And here will be the maximum height. So at the maximum height here, the vertical velocity is gonna be equal to 0 meter per second, and the initial velocity is equal to v. And you can separate the velocity v into vertical component and horizontal component. So this is theta. Then initial vertical velocity is gonna be equal to v sine theta, and initial horizontal velocity is gonna be equal to v cosine theta. So you can calculate the time to reach maximum projectile motion first. So time is equal to change in velocity, which is equal to final velocity minus initial velocity over gravitational acceleration. So gravitational acceleration is the only acceleration acting on a projectile if we ignore a resistance. And time must be an absolute volume, so we are gonna put a absolute sign here. So this is gonna be equal to v sine theta over g. So this is time. And we know height is gonna be equal to average velocity. So final velocity plus initial velocity divided by 2 times time. And final velocity here is gonna be equal to 0. So it's gonna be equal to v sine theta over 2 times time. So this will give us the equation of v squared times sine theta squared divided by 2g. So the answer will be A. A block of weight W is suspended by 2 strings of equal lengths. The strings are almost horizontal. What is correct about tension T in one string? So one thing to underline here is the strings are almost horizontal, meaning that the theta here is extremely small. So how do we solve this problem? So you know a force of tension T is applied by both strings, and they have the same magnitude of force since they're suspended by 2 equal lengths and their angle are equal to each other. So this is, we can draw a free body diagram first. So I know this is not really accurate here, but we are just drawing this as a demonstration. It probably looks something like this. And then here is a theta, angle of theta. So you can separate them into vertical component and horizontal component. And you will find out that the horizontal component is gonna cancel out with each other. And you only have 2 vertical component. And the vertical component here is gonna be equal to t sine theta. So t sine theta. Here. So 2t sine theta is equal to mg, is equal to the weight of the block. So t sine theta is gonna be equal to weight over 2. And from this we know that tension must be greater than weight over 2. So A and B are immediately wrong. So now how do we solve this problem? And this is where the difficulty comes for this problem. So what I do is I said if tension is equal to weight, what's gonna happen? So if tension is equal to weight, and then I will plug this equation here into this one. So weight sine theta is gonna be equal to weight over 2. Then sine theta is gonna be equal to 1 over 2. Then theta is gonna be equal to 30 degrees. And since the strings are almost horizontal, it cannot be 30 degrees because 30 degrees is way too large. So the only option we have here is D. So this problem is a little bit tricky. 2 cars, X and Y, are traveling towards a junction. The velocity of car X is v sub x, and the velocity of car Y is v sub y. Which of the following vectors represent the velocity of y relative to x? So here we are testing about relative motion. So what is the velocity vector that represents velocity of y relative to relative to x? So when they say relative to x, here's gonna be the system. And from from x perspective, because y is approaching to x, there's gonna be a velocity vector that point upward. And because x is also approaching to y, so it's gonna feel that y is getting closer and closer to x, right? So it's also gonna have a vector that point to the left direction. So the net vector here is gonna be this one. So D is the correct option. So here is where is a little bit hard to understand. Is this vector here. If you draw a vector that point to right direction, the net vector is gonna be something like this, which is wrong. So remember, relative motion, you're observing things from x. So gotta think from x perspective, right? Car x, because it is moving to the right, but because it is a system, so it's gonna feel like that something is approaching to it. So the vector is gonna point to the left, and this is why D is the correct answer. A ball starts from rest and moves horizontally. 6 positions of the ball are thrown at a time interval of 1.0 millisecond. The horizontal distance between x, the initial position, and y, the final position, is 0.05 meters. What's the average acceleration of the ball between x and y? So we know the time interval between the 6 positions, so we can calculate the total time. So how many intervals do we have? 1, 2, 3, 4, 5. So the total time is going to be equal to 5.0 millisecond, which is equal to 5.0 times 10 with the power of negative 2 seconds. And then we can calculate the average acceleration. Actually, it should be power to the negative third power, I think. So we know the total horizontal displacement here is equal to 0.05 meters. We know the total time, and we are asked to calculate the acceleration. So how do we solve this problem? So we know that displacement is equal to a half times acceleration times t squared plus initial velocity times time. And because the ball starts from rest, it's gonna have an initial velocity of 0 meters per second. So here is gonna be equal to 0, right? So now we can just plug in different number to calculate acceleration of the ball between x and y. So 0.05 is gonna be equal to a half times acceleration times 5.0 times 10 to the negative third power square. And then after calculation, you will find out that the acceleration is gonna be equal to 4,000 meter per second square. So the answer is B. A parachute of total mass 70 kilograms is falling vertically through the air at a constant speed of 8 meters per second. What is the total upward force acting on the parachute? So because the parachute is moving at a constant speed, then the resultant force of the system must be equal to 0. So there's a downward force of gravity acting on the parachute, and it is equal to mass times gravitational acceleration, which is equal to 7 Newton. So in order to cancel this force out, there's gonna be a force that points to the opposite direction by equal in magnitude. So this is the upward direction, and the magnitude of the force will also be equal to 700 Newton. So the answer will be D. A student is sitting on a chair. One force is acting on the student is the pull of gravity. According to Newton's third law, there must be another force, which is what? So according to Newton's third law, each applied force has a reaction force that's equal in magnitude but different in direction, right? So you know, because gravity is pulling downward, firstly this direction must be upward. Right? So B and C are wrong. and we also have we only have A and D, the upward push of the chair on the student, and the upward force on Earth. So now how do we do this problem? So we know the force acting on the student is the pull of gravity that is applied by Earth. So the reaction force must also be acting on Earth. So D is the correct answer. So this one is testing about Newton's third law. Action force is equal to reaction force. And the force must be acting on the same object. So if a person punch a wall, then they also receive a force. The person also receive a force that's equal in magnitude but different in direction. So this one, the gravity is the applied force of gravity is by Earth. So the reaction force must be opposite in direction, which is upward, but it gotta be acting on the same object, which is also the Earth. So D is the correct answer. A cyclist accelerates in a straight line. At one instant, when cyclist is exerting a forward force of 14 newtons, the air resistance is 10 newton. What's the rate of momentum of the cyclist at this instance? So change in momentum. How do we calculate change in momentum? So change in momentum is equal to net force times change in time. And net force in this scenario, there's a forward force of 14 newton and a resistance of 10 newton. So the net force is going to be equal to 30 newton. So rate of change in momentum, so meter per second, force times second. So you want to know the rate of change of momentum, right? So rate of change of momentum is equal to change in momentum over change in time, which is equal to net force. So here, basically they're asking you to calculate net force, which is equal to 30 newton, right? So the answer will be B. A stationary nucleus of polonium-210 undergoes alpha decay from form lead 206. The initial speed of the alpha particle is V. What is the speed of the lead 206 nucleus? So this one is asking about conservation of momentum. So for conservation of momentum, we know initial momentum gotta be equal to final momentum. An alpha particle is identical with helium that has an atomic mass of 4 and proton number of 2. So initial momentum is gonna be equal to final momentum. So a mass of 4 times initial velocity is gonna be equal to final momentum. So a mass of 206 times final momentum. So VF is gonna be equal to 4V over 206. So D is the answer. A tennis ball is drawn from the top of a tall building. Air resistance is non-knowledgeable. Which graph shows the variation with time of the displacement mass of the ball? So we know air resistance is non-knowledgeable, and a ball is drawn from a tall building. So it's gonna reach its terminal velocity. So the graph of velocity versus time is gonna be something look like this. And velocity is gonna be constant when it reaches its terminal velocity. So we know the velocity versus time graph, and we need to know displacement versus time. So for this part here, it has a constant velocity. And we know the gradient of displacement versus time graph is equal to velocity. So let me write this down. Gradient of displacement versus time is equal to velocity. So here, if it has a constant velocity, it means that the gradient must be constant. So it's gonna be something look like this. Right. So this is the velocity, and now we only need to solve for this one. So we know the velocity here is increasing in volume, so velocity increases, which means the gradient of the graph of displacement versus time also increases. So if increases, it's gonna be something look like this. So A is the answer, and we can double check. So as long as we know there's gonna be a linear line here, we know that B and D are not correct. So now we only need to check the gradient here. So let's check the gradient. So this gradient here, you just draw a tangent line of something like this, and then this, and then this, and then this, and eventually become constant. So the gradient increases, meaning that the velocity increases. And for C, the gradient initially looked like something like this. And then something like this, this, and this. So the gradient increases, meaning the velocity the gradient decreases, meaning the velocity decreases, which contradict with the graph here. So A is the correct answer. An object of mass 2 kg is thrown vertically downward with an initial kinetic energy of 100 joules. What is the distance falling by the object at the instant when its kinetic energy has doubled? So initial kinetic energy is equal to 100 joules, and final kinetic energy is equal to 200 joules since it has doubled. So changing kinetic energy is gonna be equal to 100 joules. Right. And we know changing kinetic energy, meaning that energy gain must be equal to energy lost, since energy must be conserved in a system. So if it falls, it gains more kinetic energy, but its gravitational potential energy must be decreases. So how much is gained in kinetic energy must be how much decreases, or how much is lost in gravitational potential energy. So changing kinetic energy is equal to changing gravitational potential energy. So 100 joule is equal to mass times gravitational acceleration times changing vertical displacement. So 100 joule over mass times gravitational acceleration. So 2 times 10 is gonna be equal to changing vertical displacement, which is equal to 5.0 meter. And this is how much distance is fall in this instant. So the answer is B. A stopper of mass 8 kg leaves the opening of a container that contains pressurized gas. The stopper accelerates from rest for a time of 16 milliseconds and leaves the container at a speed of 200 meter per second. What is the order of magnitude of the force acting on the stopper? So how do we calculate the force acting on the stopper? So we know the mass, we know change in time, we know the final velocity, and we also know initial velocity. Right. So since it's accelerated from rest, the initial velocity is gonna be equal to 0 meter per second. So how do we do this problem? Well, we know that force times change in time is equal to impulse, and impulse is equal to change in momentum, which is equal to mass times change in velocity. So final velocity minus initial velocity, and velocity in this case is equal to 0, since it accelerates from rest. So force times delta t is gonna be equal to mass times final velocity. And now we can calculate final velocity. So final velocity is equal to force times change in time divided by mass. Hold on, it's asking us to calculate force. Sorry. So force is equal to mass times final velocity. So a kilogram, you gotta convert that to kilogram. So here's 8 grams. So a times 10 to the negative third power times final velocity, which is 20 meters per second over change in time. So 16 times 10 to the negative third power. So this is gonna be equal to y. So here it cancels off. So it's gonna be equal to 20 times a, which is equal to 160 divided by 60 divided by 16 is gonna be equal to 10 Newton, right? So the answer will be C. The order of magnitude of the force is equal to 10 Newton. So I just want to clarify a little bit. So this is the order of magnitude, and this is also equal to the magnitude of the force acting on the stopper. However, if if one question the force is equal to, let's say, 300, then it's going to be equal to 3 times 10 to the second power. Then 10 to the second power will be the order of magnitude. A body is moving in a straight line. A force F acts on the body in the direction of the body's motion. A resistive force F acts on the body. Both forces act along the same straight line as the motion of the body. The rate of change in momentum of the body is equal to y. So rate of change of momentum is equal to net force acting on the body. So how do we calculate this one? So we know there's a force F, and we also know there's a resistive force that must be pointing in the opposite direction with F. So the net force is gonna be equal to capital F minus a resistive force, so lowercase f. So this is equal to the net force. So A is the answer. A mass is suspended from the ceiling of a train carriage by a string. The string makes an angle theta with a vertical when the train is accelerating along a straight horizontal track. What's the acceleration of the train? So the string here must apply a force of T, a force of tension represented by the letter T. And then you can separate them into vertical component and horizontal component. So here it's gonna be equal to T cosine theta. So this is a vertical component. And the horizontal component is gonna be equal to T sine theta. So here T cosine theta and T sine theta. Oh, sorry, I think I mix up something. Oh, the vertical component is T cosine theta. Sorry. And the horizontal component is T sine theta. Yes. And we know there's also gonna be a force of gravity acting on the mass. Right. And since it says the train is accelerating along a straight horizontal line, this tells us the vertical component. The net force in the vertical direction must be equal to 0 Newton. So T cosine theta is gonna be equal to the weight of the mass, so equal to mg, and then the force in the horizontal direction, so T sine theta is gonna be equal to the net force, so mass times acceleration. So now from this we know that tension is equal to mg over cosine theta, And from this, we know acceleration is equal to t sine theta divided by mass. And then you can plug this equation here, the equation for tension, into the equation for acceleration. So acceleration is going to be equal to mg over cosine theta times sine theta over m. So this is going to be equal to mg tangent theta divided by mass, which is equal to g tangent theta. So the answer will be C. Two identical balls are dropped from a tall building. One a few seconds later, the other. Air resistance is non-knowledgeable. As the balls fall, the distance between the balls will weigh. So we know that vertical displacement is equal to a half times gravitational acceleration times t squared. So let's say this is for the first ball. So for the second one, it's going to be equal to a half times gravitational acceleration times t2 squared. So delta H is going to be equal to a half times gravitational acceleration times t1 squared minus t2 squared. So from here, we know that initially the distance between two objects is going to increases. However, because air resistance is non-knowledgeable, they're going to reach terminal velocity. So acceleration is going to be equal to 0, and both are going to be moving at constant velocity. So moving at a constant velocity, the distance between two objects will remain constant. So the answer will be C. Which of the following quantity can be determined from a speed time graph of a particle traveling in a straight line? So speed and time graph. We know that the gradient is gonna be equal to the magnitude of acceleration. So absolute volume of acceleration. And we know area on the curve is gonna be equal to distance. Right? It's gonna be equal to distance, which is So gradient is equal to the magnitude of acceleration, and area is equal to distance, which is equal to the sum of the absolute volume of displacement. So A says only the magnitude of acceleration at a given instant. This is wrong because you can also determine distance. B says both velocity and acceleration at a given instant. So B is also wrong because vector velocity and acceleration are vectors, while the magnitude of acceleration and distance are scalar quantities. Only the distance traveled in a given time. This is wrong because you can also determine the magnitude of acceleration and distance. D says both distance traveled in a given time, the magnitude of acceleration at a given instant. So D is the correct answer. A truck is put up an inclined plane at a constant speed by an electric motor. The gain potential energy is 48 kilojoules. The efficiency of the electric motor is 2/3. How much energy is dissipated in pulling the truck up the plane? So the term dissipate basically means how much energy is wasted during the process of pulling the truck up the plane. So we know efficiency is equal to useful energy over total energy. So the gain potential energy is equal to 48 kilojoules. So the total energy we don't really know, but we know the efficiency is equal to 2/3. So from this we can calculate the total energy, right? So the total energy is gonna be equal to 3 times 48 divided by 2, which is equal to 3 times 24, which is equal to 32 kilojoule. Right, and we know useful energy is equal to 48 kilojoule. So we can also calculate how much energy is wasted. So how many energy is wasted is equal to total energy minus useful energy, which is equal to 72 minus 48 is equal to 24. So the answer is 24 kilojoule. A football is kicked with an initial velocity u at an angle theta to the horizontal and reaches ground t seconds later, ignoring a resistance. What's the range of the football? So we know that the horizontal velocity remains constant during a projectile motion. And if this is the initial velocity, then the initial horizontal velocity is going to be equal to u cosine theta. So to calculate displacement or range of the football, we only need the initial velocity times change in time. So it's going to be equal to u cosine theta times d. So the answer will be B. Which of the following is always true for an object moving in a straight line at a constant velocity? So no forces acting on the object. This is wrong, because as long as the resultant force of the system is equal to 0, it's gonna move at a constant velocity. No resultant force acting on the object. This is true. The momentum of the object is 0. This is wrong, because momentum is equal to mass times velocity. So the change in momentum can be equal to 0, but the momentum can be a non-zero value. No work is being done on the object. So work is equal to force times displacement times cosine theta. So this is also wrong. A student throws a stone with velocity v at an angle theta to the vertical from the surface of a lake. Air resistance can be ignored. The acceleration due to gravity is g. What is the time taken for the stone to hit the surface of the lake? So this is the initial velocity here. And then you can separate them into a vertical component. Here is the angle theta. So the vertical component is going to be equal to v cosine theta. And the horizontal component is going to be equal to v sine theta. And we know when an object reaches its maximum height in a projectile motion, it's going to have a vertical velocity of 0. So time is going to be equal to change in velocity, change in vertical velocity, divided by acceleration, which is equal to gravitational acceleration. So here you're gonna take the absolute volume. So it's gonna be equal to 0 minus initial vertical velocity, which is equal to v cosine theta over g. So this is equal to v cosine theta divided by g. So this is the time to reach the maximum height. However, it asks the time taken to hit the surface of a lake. So the total time, you need to multiply by 2. So D is the correct answer. I just want to point out that this one is true because it says air resistance can be ignored. So when air resistance can be ignored, we assume that the trajectory of a projectile motion is symmetry. Right? So it takes an equal amount of time to complete half of the horizontal displacement. However, if air resistance is not knowledgeable, it's gonna be something look like this. Right. To be more accurate, it's something look like this. To isolate a spherical planet has the same gravitational potential at their surface, which ratio must also be the same for two planets. So if you have learned the chapter of circulation and gravitation, we know that gravitational potential energy is equal to G over R. Actually, GM1 2 over R, right? If you haven't learned this chapter, don't worry about it. I think it's topic 4 or topic 5 or topic 6. I'm not really sure. So this is the formula you will be learning in the chapter of gravitation. So they have the same potential energy, so you can write a equation for it. Right? So G1, so the first spherical planet, 2 over R is gonna be equal to G2 3 over R R2 R1. So now you can just cancel all stuff. So G and G cancel out, M2 and M2 cancel out. Right. So all you have is M2 over R2 must be equal to M1 over R1. So the ratio of mass over radius gotta be equal, and you can take their reciprocal. So radius over masses must also be equal to each other. So C is the correct answer. If a moving object is subject to a constant force, which of the following can be correctly deduced from Newton's first law? So constant force is equal to mass times acceleration. So if there's acceleration, the velocity gotta be changing. So A is the correct answer. Which of the following is necessary for an object to be in transitional equilibrium? So I think we have done this before. So the resultant force acting on the object must be equal, because the object can be both in stationary or moving at a constant velocity. A toy car of mass 0.15 kilogram accelerated from a speed 10 centimeter per second to a speed of 15 centimeter per second. What is the impulse acting on the car? So impulse is equal to change in momentum, which is equal to the mass of the object, 0.5 kilogram, times change in velocity. So final velocity, 15 centimeter per second. I'm gonna convert that to meter per second. So times 10 to the negative second power, and then minus initial speed. And you also convert it to meter per second as well. And this is gonna be equal to 0.0075 Newton per second, which is equal to 0.5 millinewton per second. So the answer is A. Which statement apply to an object in transitional equilibrium? So we also have done this problem before. So the resultant force must be equal to 0. A gun fires a bullet of mass at a horizontal speed v. A resistance on the bullet is negligible. A change in which of the following will affect the time for the bullet to hit the ground? So one important concept: mass does not affect motion at all. In fact, mass never affects the motion of an object if a resistance is negligible. So here's the scenario. Velocity v. How do you calculate time? So we have the vertical displacement here is h. So vertical displacement is equal to a half times gravitational acceleration times t square if its initial velocity is equal to 0. So time is equal to the square root of 2h over g. So mass does not affect the time to reach the surface. The horizontal velocity also does not affect the time. So the answer is D. A net force of magnitude 4.0 Newton acts on a body of 3.0 kilogram for 6 seconds. The ball is initially at rest. Which of the following is the speed of the object after 6.0 interval? So this one is asking you to find the final velocity. So impulse is equal to change in momentum, and impulse is equal to net force times delta t, which is equal to m times change in velocity, right? And we know that body is initially at rest, so if initial velocity is gonna be equal to 0, so this is equal to change in momentum is equal to mass times final velocity. So final velocity is equal to force times change in time, so 4.0 times 6.0 over final velocity, over mass, which is equal to 3. So this is gonna be equal to 24 over 3, which is equal to A. So the answer is D. An object moves in the xy plane. The graph shows how the component of the velocity vx in the x direction and the component of its velocity in the y direction vary with time v. So here's a graph. Its horizontal velocity remains constant, and its y velocity decreases at a constant rate, meaning there's gotta be a constant vertical acceleration. So the particle is moving away. So we know it cannot be b because simple harmonic motion, if vertical velocity first decreases and then increases, right? So it cannot be b. And the answer is gotta be A in a parabola, right? Because in a parabola, the object has a constant horizontal velocity, and vertical velocity is always affected by a gravitational acceleration. Right. So A is the answer. The graph shows the path of projectile that is launched with a velocity v. Where resistance is negligible. A second projectile has double the mass of the first projectile and is launched with the same velocity. Air resistance is still negligible. Which of the following paths best describe the path of the projectile? And the original path is shown as a dotted line. So for this problem, you need to know that mass does not affect motion. So their projectile motion, their trajectory is gonna be identical to each other. So D is the correct answer. A car moves from X to Y along a semicircular path. The radius of the path is 250 meters, and the time taken to complete the trip is 15 seconds. Which of the following correctly shows the magnitude of the average velocity and the magnitude of average speed? So average velocity is equal to displacement divided by change in time, which is equal to initial position minus final position minus initial position. So this is the final position. This is equal to the initial position. So displacement is gonna be equal to the length of the right line here, which is equal to the diameter of the circle. So it's gonna be equal to 500 meters divided by change in time, which is 50. So it's gonna be equal to 10 meters per second. And the average speed is equal to distance divided by change in time, which is equal to the length of the actual path traveled by the object. So it's equal to the length of the green line here. So as long as you know the average velocity, you know that the length of the gray line is gotta be greater than the length of the red line. So you can immediately know the answer cannot be A, it cannot be D. And since distance is larger than displacement, then we know that speed must also be greater than velocity. So B is the answer. You can also calculate to check your answer. So average speed is gonna be equal to half of its perimeter. So 2 pi times r divided by 2, which is just equal to pi r divided by change in time. right? So this is gonna be equal to 5 pi. Pi is equal to 1.3.14 something, which is approximately equal to 16. So B is the correct answer. An object is drawn from rest. Air resistance is not knowledgeable. What is the acceleration of the object at the start of the motion? So air resistance is not knowledgeable. So this is the force of gravity by Earth, or drag force by any planet. Or gravitational attraction force by any planet. And this is a drag force. So drag force is gonna increases, which means acceleration is gonna decreases. So the answer is C. A ball of mass m collide with a vertical wall with an initial horizontal speed u, and then it rebound with a horizontal speed v. The graph shows the variation of the speed of the ball with the time. What is the magnitude of the mean net force on the ball during the collision? So we know impulse is equal to net force times delta t, which is equal to change in momentum, so m times change in velocity. So this is equal to mass times final velocity minus initial velocity. So we can calculate the change in momentum first by using the graph. So change in momentum is equal to mass times final velocity minus initial velocity. But here, since this only shows us the speed, only shows the magnitude or the absolute volume of the velocity, so we need to think about what really happened during the process. So this is the initial velocity of the ball. So it has a velocity of u, and then it rebounds with a speed of v, right? But because velocity is a magnitude, it's a vector quantity. So if you take vector forward, direction also matters. So there gotta be a negative sign in front. So this is gonna be equal to m times negative v minus u, which is equal to m times v plus u with a negative sign in front of the equation. But since we are talking about the magnitude of the mean net force, we are gonna take the absolute volume of this quantity, which is equal to m times v plus u. And now we can calculate F. So F is gonna be equal to the magnitude of change in momentum divided by delta t. And delta t is equal to t2 minus t1. So the answer will be will be D, sorry. Two steel balls of mass m and 2m fall at a constant speed in a tube filled with oil. Which of the following correctly compares the magnitude of the net force and the drag force on the two balls? So since they are both falling at a constant speed, their net force are all equal to 0 Newton. But they have a different drag force, because drag force is equal to 6 pi times velocity times their radius and then times their velocity. So since they have different mass, their volume is gonna be different, and if they have a different volume, their radius is also gonna be different. So they have same drag force but different net force. So the answer is B. Which of the following is a correct definition of work? So this one is about your conceptual understanding of work. So work is equal to this equation here. So B is the correct option. Work is defined as a product of force and distance moving in the direction of the force. The graph shows the variation of the acceleration a of an object with time t. What is the change in speed of the object shown by graph? So this question is testing about your understanding of motion diagram. So for acceleration versus time graph, the area under curve represents change in velocity, and the gradient represent does not have a physical parameter. So to calculate change in speed of the object, you just need to calculate the area under curve. So, hold on. So the area here is equal to 1/2 times 6 times 12, which is equal to 3 times 12 is equal to 36. So the answer is C. A horizontal spring of spring constant K and knowledgeable mass is compressed through a distance y from its equilibrium length. An object of mass m that moves on a frictionless surface is placed at the end of the spring. The spring is released and returned to its equilibrium length. What is the speed of the object just after it lifts the spring? So for this problem, it's a little bit tricky because you need to know that at the equilibrium position, the object has a velocity of 0. So one way to understand is this. When it moves in the left direction, it has a negative velocity. And it moves, when it passes the equilibrium position, it moves to the right direction. So it's going to have a positive direction. So at the equilibrium position, it gotta have a velocity of 0 meters per second, right? And this is how we know its velocity at the equilibrium position. Right. And now you can use conservation of energy to solve this problem. So we know energy gain must be equal to energy loss, since the total amount of energy is conserved in the system. So when the spring is compressed and then released and returned to its equilibrium position, its kinetic energy changes and its spring energy also changes. So the amount of change in kinetic energy, or how much kinetic energy is lost, is equal to how much spring potential energy is gained. So 1/2 times mass times VF squared, so final velocity squared, minus initial velocity squared is equal to 1/2 times spring constant times y squared. So y is the amount of distance the object moves. So the 1/2 here cancels off. And the final velocity is the velocity at the equilibrium position, which has a value of 0. Now we have m times vi squared with a negative sign is equal to ky squared. And since the question is asking us the speed, so we are only going to take the magnitude. So we don't really care about the negative sign here. So now we can calculate the initial velocity. It's going to be equal to the square root of ky squared over m, which is equal to y times the square root of k over m. So the answer is A. A stone is thrown from a cliff and is landed in the sea as shown below. Air resistance is knowledgeable. Which of the following statement is correct while the stone is in motion? The vertical component of the stone displacement is constant. We know this is wrong because the stone is in motion, so its vertical position changes, which means that its vertical component of displacement cannot be constant. So A is not correct. B says the horizontal component of the stone displacement is constant. This is also wrong because its final position is here while its initial position is here. So its horizontal displacement, where its horizontal position also changes. So B is also wrong. Now C says the vertical component of the stone is constant. So during projectile motion, object is always affected by gravitational acceleration by the planet, and this acceleration remains constant. So if there is a acceleration in the vertical direction, the final velocity changes. So the velocity cannot be constant if there is acceleration. D says the horizontal component of the stone's velocity is constant. This is correct because if this is the initial velocity, then its horizontal velocity always remains constant. Right? So here's the theta, and here's the initial velocity. So D is correct. Ball X and Y are at the same height. X is projected horizontally at the same time that Y is dropped. Y is the same size as X, but half of its mass. Ignoring air resistance, which statement is true? So Y will hit X before or after or at the same time. So we know that mass does not impact motion. So the amount of time for them, for x and y to hit the ground is gonna be equal. So C is correct. If you don't see y, you can see this from your kinematic equation. So we know when it hits the ground, it both travel the same amount of vertical displacement. And vertical displacement is equal to initial velocity times time multiply a half time acceleration times t square, and we ignore the air resistance here. So initial velocity is equal to 0. And the acceleration is always going to be gravitational acceleration. So it's always equal to a half time gravitational acceleration times t square. So t is going to be equal to the square root of 2h over g. So this is equal for both x and y despite their mass are different. So it's going to take the same amount of time for them to hit the ground. A ball is thrown from point X and follow the path X, Y, Z. Air resistance is negligible. Which quantity is 0 when the ball is at the highest point Y of the path? The horizontal component of the ball acceleration. So this is correct because in a projectile motion, the horizontal acceleration is always equal to 0 when air resistance is negligible. So it is correct. The vertical component of the ball acceleration is always a non-zero acceleration. So in the vertical direction, the object is always impacted by the gravitational acceleration by Earth or by any planet. So its acceleration is always a non-zero value. C says the horizontal component of the ball acceleration. So the horizontal component of the horizontal component of the ball's velocity remain constant, but it still has a velocity, right? So if this is the initial velocity v, then it's always gonna have a velocity of vx. If here is theta, then vx is gonna be equal to v cosine theta. So this velocity, the horizontal velocity, remain constant, but it does not equal to 0. The kinetic energy of the ball. So since here we have a horizontal velocity, the kinetic energy will also be a non-zero number, so D also wrong. A ball of mass m is thrown horizontally from a cleave with an initial velocity u. Air resistance is negligible. A change in which of the following will affect the horizontal distance traveled? So initial velocity, initial horizontal velocity, and mass. So horizontal velocity is equal to horizontal distance is equal to horizontal velocity multiplied by time, right? And this is equal to u times t. So only these two quantity, its initial horizontal velocity and time, will impact on the horizontal distance traveled. So mass does not impact motion is wrong. U only, this is correct. Both m and u, so mass does not impact at all. So C and D are both wrong. An object is thrown horizontally from the edge of a high crater on the moon. The moon has no atmosphere, meaning that no drag force exists. Which of the following describe the changes, if any, to the horizontal and vertical component of the velocity of the object? So the object is thrown vertically, right, from a cliff. So its horizontal velocity is gonna remain constant since there is no acceleration. So B and D are wrong. The vertical velocity, so since there's no drag force, the only acceleration will be gravitational acceleration by moon. So if there's a constant acceleration, right, then its vertical velocity gonna be changing at a constant rate. So A is correct. The horizontal component v sub h and vertical component v sub v of velocity of an object are shown on the graph. Air resistance is negligible. This graph could represent the motion of an object fired from a cleave vertically upward at an angle above horizontally, or at an angle below horizontal. So here we know the initial vertical velocity is a non-zero number, so it cannot be shoot at an angle below the ground, because if it does, then its initial vertical velocity gonna be a negative number, so D is wrong. And if the object is fired horizontally, then it's gonna have an initial vertical velocity of 0, so C also wrong. So vertically upward, then the horizontal velocity gonna be 0, so A is also wrong. At an angle above the horizontal, so you're gonna have a non-zero or positive initial vertical velocity, and the velocity decreases at a constant rate because gravitational acceleration. So this is correct, and also have a constant and non-zero horizontal velocity, so B is correct. The resultant force acting on an object of mass 5.0 kilogram vary with time as shown below. The object is initially at rest. What is the speed of the object after 1 second? So we know the time, we know the force, we also know delta t, and we are asked to find what? We're asked to find the final velocity after 1 second. So when you see all of those quantity of force, change in time, velocity, and you also know mass, you need to think of impulse. Impulse is equal to net force times delta t, which is equal to mass times change in velocity, and change in velocity is equal to final velocity minus initial velocity. And since the object is initially at rest, here it's gonna be equal to 0 meter per second. So F times delta t is equal to mass times final velocity. And here's the graph. The area under curve basically represents impulse, because resultant force times delta t. So here we just need to calculate the area under curve first to calculate impulse. So this here is equal to 0.5 times 10 is equal to 5. Here is equal to 0.5 times 5 is equal to 2.5. So the total area is going to be 7.5. So 7.5 is equal to mass times final velocity, and mass has a unit of 5.0. So final velocity is going to be equal to 7.5 over 5, which is equal to 1.5 meter per second. So C is the answer. A sunbather is supported in the water by a floating sunbath. Which diagram represents the magnitude of the forces acting on the sunbath? So there's 3 forces on the diagram for total. One normal force, one upward normal force, the weight of the person on the sunbath, and the weight of the sunbath. And in order to be them to be stationary, they're gonna have a net force of 0, and the length of their force vector represent the magnitude of their forces. So here, if you move this arrow here, you will see that the upward arrow is much longer than the downward arrow, meaning that the upward force is larger than the downward force. So the system is not balanced. So A is wrong. And here, if you move this arrow here, you will see that the downward force is much larger than the upward force. So B also wrong. And here, same thing, you will see the downward force is larger than upward force, so C is wrong. And here you will see that they are equal to each other, so D is the correct answer. A ball of mass m is projected horizontally with speed v from a height h above the floor. Air resistance is negligible. The horizontal distance traveled by the ball to the point where its length depends on what. So we know that horizontal displacement is equal to its initial horizontal velocity v times change in time t, right? And mass does not affect the motion, and you can calculate time from vertical displacement. So h is gonna be equal to a half times g times t squared. So t is equal to the square root of 2h over g. Okay. So those are quantities that impact the amount of horizontal displacement the ball travels. So m does not impact, we know this. B does not impact, so A, B, D are wrong. So only C is the correct option. A speedboat tools a water skater, so the skater accelerate. The magnitude of the force exerted on the skater by the tow rope must be greater than the magnitude of the total resistive force acting on the skater, equal to the magnitude of the force exerted on the tow rope by the skater, equal to the magnitude of the force causing the boat to accelerate. So which of the factors is or are correct? So let's take a look at them one by one. So the magnitude of the force exerted on the skater is this force here, must be greater than the resistive force acting on the skater. So this is correct. So when the skater accelerates, there's gonna have a acceleration A here, and this net force is equal to this capital F minus the resistive force F. So F must be larger than the resistive force. So the first one is correct. The second one says equal to the magnitude of the force exerted on the toe by the skater. So this is also correct because tension is same throughout a string. So to be more specific, the frictional force F shouldn't be drawn here. It should be here. Right. So this is where friction comes from. And here, this force here is asking you about the tension in the string. So they are equal to each other. So this one is also correct. The force exerted on the skater by the tow rope must be equal to the magnitude of the force causing the boat to accelerate. So this is wrong because you also have friction. So that force does not equal to this force F here, but equal to this equation here. Right. So third one is wrong. So A is correct. A student draws a graph to show variation with time t of the acceleration a of an object. What can the student deduce from the graph? A student draws a graph to show the variation with time t of the acceleration a of an object. What can the student deduce from this graph only? And what quantity from the graph is used to make this deduction? So change in velocity, gradient. So remember the gradient of acceleration versus time graph does not really have any physical meaning. So the only thing you need to know from acceleration versus time graph is that the area under curve represents change in velocity, right? And you can all deduce displacement from acceleration versus time graph because that requires velocity versus time graph. So change in velocity is going to be equal to area under the line. This is true. So for change in displacement, if you have a velocity versus time graph, then the area under curve represents change in displacement. A ball is thrown horizontally from the top of a high cliff. Air resistance is negligible. Which of the following correctly describe the changes, if any, to the ball's vertical speed and horizontal speed? So it's thrown horizontally from a cliff, meaning that its horizontal speed gonna remain constant, and since the only acceleration acting on the object is gravitational acceleration, so its vertical speed gonna increases, right? So B is the correct answer. So here is increases because we are talking about speed. If this is talking about velocity, then the answer is gonna be D, right? If you don't see why, you need to think about vector and scalar. So it's gonna have an initial a vertical velocity of 0. So its final vertical velocity is gonna be equal to gravitational acceleration times time. And for speed, you're gonna take this acceleration as a positive volume. so it's gonna increases as time increases. But for velocity, you're gonna take the acceleration as a negative volume, so it's gonna decreases. So B is the correct answer for this problem. A ball is thrown from the top of a cliff. The initial magnitude of the velocity of the ball at time t equal to 0 is v. The ball hits a sea at time t is equal to capital T. A resistance is knowledgeable. Which graph shows the vertical component of the velocity v of the ball vary with time t as it falls to the sea? So we know B is definitely wrong, because when it falls, it's gonna have a negative velocity. So the velocity of 0 meter per second is at this point, at the highest point. But when as long as the ball passes this point, it's gonna have a negative velocity. So B is wrong. Another thing is we are talking about vertical component. So vertical component here, initial velocity is equal to v. Let's say here is theta. Then initial vertical velocity, I'm gonna use v sub y to represent vertical velocity. It's gonna be v sine theta. And from trigonometry or from visualizing the triangle, we know that v sine theta is always less than v. So v sub y is always less than initial velocity v. So here, this must be wrong because its initial vertical velocity cannot be greater than initial velocity. In fact, it is less than initial velocity. So A is wrong. So we only have C and D. Right? So we know they both cross. They both has a intercept here that represents 0 meter per second. But here, this one is much shorter than this one. And when we look at the graph, we know that here, to reach its highest point, here, this has a smaller vertical position. So H1 is less than H2, meaning that T1 must be also less than T2. So here, C is also wrong because this part here basically represents T1 and this part represents T2, right? But we know T2 must be greater than T1, so D is the correct option. A girl is standing on a moving skateboard. She pushes backward on the graph at the time interval as shown on the graph. So forces versus distance. How much kinetic energy is gained by the graph during the period represented by on the graph? Friction forces are knowledgeable. So kinetic energy. So we know that work done is equal to change in kinetic energy. And work is equal to forces times displacement, which is represented by area on the curve here. Right? So we need to calculate area on the curve. So for triangle here, it's going to be equal to 5 times 18 times a half, which is equal to 200. And here is also 200. Here is also 200. So the total work done is equal to 600, which is equal to how much kinetic energy is gained.